everybody, and welcome back to another video in this series. So in this video, we will finally be going over the UpdateStates function that we see in the game animation sample project. So this one, I want y'all to all be more, I guess, acute with, or more aware of, or at least the most knowledgeable on this part, because a lot of the chooser table, especially with our animations and how things are set up in chooser tables, do come from this function in particular, because this is where it houses all of our enumeration files that give us the thing like, hey, are we, orienting to rotation? Are we idle, on ground? Are we moving, walking, idle, running, sprinting? Are we crouching, standing, etc.? Like all those different, variables that come with our chooser table that allow us to switch between the different, states and get the proper animations. So this one should hopefully be a pretty fun one because, this actually opens up a lot of the doors that come with the motion matching setup. So let's go ahead and jump right into it by creating our function first, and then after that we are going to have to create a lot of enumeration files. So I'm going to go over to our functions tab over here, and I'm going to create a new function and call it UpdateStates, just like that, because now we can get into the nitty-gritty of our setup. So first thing we need to do is we need to open up our content drawer, because in the character blueprint series that I've done when we set up everything from scratch, the only enumeration file that I have set up in there would be the Gait that would have our walking, running, and sprinting speeds and stuff like that. Or sorry, that'd be our Gait speeds, but it would have our idle. It should have our walk, run, sprint within this. So just to kind of go over what we did in the character blueprint series, if we open it up, yeah, you'll see that we do have our walk, we have our run, and we have our sprint, because we will be making variables in this relatively soon, but I want to kind of go in order with how they have it within the game animation sample project. So the first thing we're going to do is we're going to go into our data folder. So if you did follow along with the character blueprint series, we will have created a data folder within our third person blueprints folder where we housed all of our enumerations, our structure files, and our curve strafe map. So in here, we're going to go ahead and create another enumeration where it will be under blueprint and then enumeration. And in here, we're going to call it movement mode, just like that. And we're going to open it up, and I'm going to dock it in here. And in here, we are going to create two enumerations to go through. And it will be, and our first one will be on ground, and then our second one will be in air. So with our movement mode, essentially with this is our method of movement, essentially, with our character. It's not in a way, it's not like the state where we're either, like idle or moving. This is basically like kind of our method of traveling. Like, how in real life with people and how they commute to work every day, or maybe commute to different activities. If you are in walking distance, people could, be on the ground walking, or, if we are flying to go to a different state or country, we would be in the air. That would be like our method of traveling, or other forms of various on-ground movement where, you would take a train or drive somewhere, ride a bike, stuff like that. So that's what we're essentially doing in here, is defining our movement method, whether we be on ground or in air. So like for example, what you could do as you get more, I would say, advanced with it, is you can do something like swimming, because you're technically not on the ground and you're not also in the air. So you can do something like swimming in here, or flying in a sense. Flying is definitely a movement mode type, because there is a default enumeration within the third person template, the first person template, and even GASP, where it's, called movement mode. It's like a built-in enumeration that will come with like many different things. Like I think it comes with walking. I believe it comes with something like nav mesh walking. falling, stuff like that. So it'll have like different methods, and you can definitely like utilize that, or kind of copy along those lines, but those would be like your different movement methods according to Unreal Engine. So now that we got that, we're going to go ahead and save it, and the next one we have to now create, so I am going to actually close that. We do now have to make another enumeration called rotation mode. So rotation mode, just like that. And then in here, it's going to be similar to how we set up the character blueprint, where we're going to have two forms of orientation for our character, where we're going to have the orient to movement. And then for our second one, we're going to have strafe, just like that. So that way when we orient to movement, basically wherever we push the directional buttons like our WASD or move our joystick around, our character will always orient their forward facing movement toward wherever we're pressing, or we just strafe. So once we got that, let's go ahead and save that. And then the next one we need to go into now is we need to create a movement state. So now the movement state is different from movement mode because it's not a method of traveling. It will be, kind of the state of our movement. Are we idling or are we actually moving? So now we're going to create another enumeration blueprint called movement state. I had to think about that for a second. And then in here, we're going to create two. And we're going to call the first one idle, and then the second one moving, just like that. And we're going to save that. And then the next one, then we already have Gait, so we don't have to create that one. But the last one that we do have to create is the stance. So we're going to create one final blueprint enumeration, and we're going to call it stance, because now this is the actual stance, or the nitty-gritty of whether we are standing or crouching, while we're either idle or moving, or, are we on ground. So let's go ahead and add two here. And the first one is going to be stand, and the second one, if I can click it, will be crouch, just like that. So now we've essentially got all of our necessary enumeration files in here. So we have our Gait, we have our movement mode, we have our movement state, we have our rotation mode, and we have our stance. So we should have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Yep, just like that. I had to double check it on my other screen, guys. So yeah, because I am trying to make sure that I go in order of what we need to do. So now what we're going to go ahead and do is let's hop back into our UpdateStates function. And what we're going to do first is we're going to drag off of the entry and get a sequence node, just like that. Because what we're going to be doing is we're going to be setting up caching references and then doing appropriate switches to ensure that we get the appropriate enumeration data for essentially all of our different types of our enumeration files. So I know that kind of sounds complex, but once we go through it, you're going to see, I'll explain, you'll see what's actually happening. So I'm going to give this a few pins because there are 5 different methods or 5 different sequences that we have to set up with our enumerations. So the first one that we will be working on is the movement mode. So in this one, I'm going to create a variable and I'm going to call it movement mode because we will be assigning the movement mode to this. So in here, we're going to type in movement mode, and we are going to get this one. So this is what I was referring to earlier when I said there is a default type for movement mode, but since we are trying to do a one-to-one with the game animation sample project, we're going to use the one that create because we've already established what we truly want out of this. So I'm going to select movement mode there, and then what I'm going to do is I'm going to duplicate this and I'm going to call it movement mode last frame. So with how this works, so let's go ahead and create the first set. So I'm going to get my movement mode and I'm going to set it in the last frame. So what this is essentially doing is with our movement mode, so let's compile and save and take a look at it, right? So when we look over here into our details panel on the right side, so with the first enumeration data that we put in movement mode, so you'll see on ground, right? So when you click the drop down, you'll see on ground and in air. So on ground is the first data type that we put in the enumeration, and then in air is the second. So what'll happen is we're trying to cache the last frame or the last movement mode used, essentially. So in the Gait, it's going to start off as on ground, because technically we're on ground. Anytime you play a video game, your character, whenever you save your game and you reload it, your character is always going to start off on ground. I don't think there's been a game that I'm aware of so far that, you know, unless it like auto saves on you, but I don't think there's a game that will legit let you just save in the air, because you're technically like not on the ground. So we're caching that into this set node, so that way we can use it for, you know, certain events where like later within the animation blueprint and other stuff, where it's like, hey, this was the last frame that was used. Because like with how I explained it, you know, when we were going through trajectory and then like the update essential values stuff, where it's gotta do this part first and then it'll execute the next part off of it, and then like loop back around to re-execute this and go through it like never-ending cycle. So that's essentially what's going to happen. So when we ever become like in a state or a movement method or mode that we are in the air, then it's going to update this to in air and then like recontinue. But then if we ever go back on ground, it'll re-loop around and put this on ground, and then, you know, like kind of do those processes. So once we have that, what we're going to do is going to drag off of here, and we're going to get a switch node, because we're trying to switch on the enumeration, but we're going to do switch on movement mode. And we're actually going to get the one that I was referring to earlier. So this one's going to be interesting, because we want to do a switch on movement mode, but we're going to be doing it off of the movement mode from our character movement. So I know we have a movement mode here, but this is not one we want to use, because this is the built-in one that I was referring to, where you have like, you know, your custom flying, falling, swimming, nav mesh, walking, etc. But what we want to grab is our character movement and get the movement mode enumeration off of the character movement, because those are built in mathematical operations and stuff like that that will detect, you know, what kind of movement mode we're doing. So in saying that, what we're going to do is in our references, we're going to grab our movement component, and then off of that, we're going to get movement mode. Should be in here. Yeah, get movement mode. This one in particular, it was one of the built-in ones. And then we're going to connect it into that. So that, like I said, so what will happen is with our character movement, because of the C++ embedded or coded, pre-built, you know, detection functions and stuff like that within it, it's going to get the appropriate movement mode to where we can then make a switch on. So that's why what we're going to be doing is like, hey, when we're, you know, walking or, you know, running, whatever, we're going to make sure that we are on ground, and then like falling, we're in the air. You can even do something like flying, be considered in the air, but you may want to do something more complex. So after doing that, what we're going to then do is we're going to go into here and grab a movement mode, and we're going to set it, and we're going to duplicate that. Because what they have going on is like, if we are, you know, if we're not walking or doing anything, then we're just kind of like idling on the ground. If we're walking, we're technically on the ground. And if we're nav mesh walking, we are on the ground, because it's still another form of, you know, detection of being moved or moving on the ground. So then once we have that, then the last thing we need to do is then just connect our falling into the second node and make sure that it is set to in air just like that. So once we have that, we're now essentially done with that first part. And what I'm going to do is, because I didn't make any special notes, because I understand what's going on, I'm just going to copy the dev notes that they have in here, because once you understand how it works, it's actually very simple with what they're referring to in their comments. So as you can see, is that we're caching the character's movement mode and saves the last frame's value. So like I said, if we are moving, on ground, it's going to cache that into here, and then it's going to then go and execute into the movement mode, where we grab our character's movement component and get the calculations that it's doing off of its pre-built Gait movement mode, and then it'll do accordingly, the movement mode with, that's linked to this. So it'll go through and do a cycle and determine whether we're on ground or in air. And then after it does the rest of its other executions, we'll loop back around to make sure that it's updated. But by the time that it updates here, we could still be either on the ground or in air, to where then it has to do another cycle, loop back to declare what the new, whether we're on ground or in air. So once we have that, what we can do is then go ahead and plug that in there and then move on to the next one. So now with rotation mode, this one is interesting. So let me go ahead and make those variables real quick. So I'm going to call it rotation mode, and we are going to grab the E rotation mode from what we've created in our enumerations. And then we're going to duplicate this and call this one last frame. Just like that. So now we're going to basically do the same thing. We're going to call in our get rotation mode, and then whatever our previous rotation mode is, we're going to cache that into a set rotation mode. So just like that. And then what we're going to be doing here is we're going to be grabbing a branch and connecting our last frame into here. If I can connect it. And then what we're going to do now is we are going to get our movement component, and then off of it our orient to movement. Because what we're doing is, again, we are going to be calling our, the cached or built-in reference with their calculations for orient, rotation, and movement. What you could also technically do with this is that you can do if you really wanted to, instead grab the character reference and get our wants to strafe, and you will essentially do the same thing. However, what you would end up having to do, so in the let me show you how the game animation sample has theirs real quick before I, can show you the alternate that you can do. So we're going to grab then the set rotation mode from the variables and duplicate that, just like how we did with the movement mode here. And then we're going to change rotation mode down here to strafe, and then mark this as true, and then mark that as false. So that is pretty much how they're doing it here. So just like in the movement mode, we're caching the current rotation mode to the last frame. As it does its cycle, it'll end up changing according to the the branch and whatnot. And then after it goes through everything else and loops back around for another execution, then we can update appropriately to what the new rotation mode is. So typically with how they're doing the orient, rotation, and movement according to the dev notes, is that the orient to movement describes when a character rotates toward the direction of movement, which would be like a traditional third-person action adventure style, while strafing would describe when the character rotates toward the camera direction in a traditional third-person shooter style. So that's why this is available for you to be able to do your chooser motion matching for if you're like aiming and other stuff, where you can set up like your orient to movement or strafe there to kind of like get those kind of styles, whether you want a 3D person shooter or an action adventure style. So now the thing that I was referring to with the condition where you could have grabbed the character reference, and then off of that you could have gotten a wants to aim or wants to strafe. So off of that you can see that our default value is true, that we do want to strafe. So you could do this as an alternative and just plug this into the condition, but then you'd have to switch the rotation mode where you would call this strafe, and then you would have to call this orient to movement. and do it that way. So this is not the only way you have to look at it. You can do it this way, since our strafing is basically also connected to our, let me see, it would be in our event graph under update rotation, where we set our use controller desired rotation and, you know, update the orient rotation to movement here based on the ones to strafe. So like I said, it's just a different way of doing it, and you would still get the same results. You would just have to then switch what the true set is and what the false set is. So now that we got that set up, we can go ahead and copy the dev notes here. And let me move those over real quick. All right, just like that. And then connect our first pin in there, and then boom, we already got 2 set up. So now the next one should be pretty interesting, because now we're going to be going into making our first pure function on this node. So first thing we're going to do is let's go ahead and do a quick setup of what this part is doing. So now we're going to be grabbing, or at least making, the movement state. So let's go ahead and make our movement state enum, and then change it to movement state, and then duplicate that and call it last frame. And then, like how we did the other ones, we're going to get our current state and we're going to cache it into the last frame. So now I'm going to start going a little bit quicker on y'all, because since we've already ran through 2, I hope that you kind of see like now what's going on. So I'm going to kind of speed it up through these next parts, because I want this to be relatively quick. So now that we have hopefully a better understanding. So like I said, we're getting the movement strafe and caching it into our last frame. And then off of this, we're grabbing a branch node. However, we have nothing to put into it yet, because now we have to make our function for it. However, what we're going to do is continue fixing this, putting it together, you know, until we are ready to make the isMoving function that we're going to be building. So we're going to go ahead and grab our set nodes for the state, and we're going to duplicate it and then line it up nicely. And so basically now we're going to be making our isMoving to determine whether we are moving or not. So if we are moving based on that function, then we need to make sure our movement state is set to moving, and then if not, we are idle. So now, ladies and gentlemen, let's go ahead and make our first node, which is actually going to be very simple, and you'll finally see what's going on. So hopefully, one of the things that I really hope y'all did is that y'all did tune into the generate trajectory video, because now we'll actually be using a variable that we created in that video. So what we're going to do now is we're going to come up here to functions. So let me actually clean up my functions real quick for y'all, so that way we don't, you know, get lost in the sauce a little bit. So what I'm going to do is I'm going to create a category and call it event graph, because now these functions are technically within the event graph. So I'm going to move all event graph related stuff into here, because as we go through it, we'll be making stuff like movement analysis, root offsets, aim offsets, additive leans, etc. So now the first one that we'll be doing, which is going to be part of the movement analysis category, is the isMoving. So let's go ahead and create the isMoving function. And basically what we're doing here is we're going to then grab our essential values, and from that we're going to grab our velocity, and we are going to then grab, I believe it's within trajectory, our future velocity. So now we get to actually finally use our future velocity. And so if you remember from the last video with the generate trajectory, is that at the end of getting our trajectory, making our future predictions, and then how we handle collision trajectories, you know, within our future, we are then setting our future velocity to a certain point in time. So what we're trying to do now to detect that we are moving and will be moving in the future is that both of these are going to be a not equals for both of these, because in order to check that we are moving and that in the future that we'll still be moving, we have to now check if our velocities are equal to 0 or not. So if we are moving, then we shouldn't have any 0 velocity values. So now we need to grab an AND boolean because we want both of these to be true, because if both of these are true, then that will mean that at the current velocity we are moving and in the future that we will be moving. So now once we got that, we then want to off of here grab a return node and then connect our AND boolean in that to then get a return value. So another reason too, rather than grabbing velocity in here and setting in here, is because what we're trying to do now, and you'll have noticed it in the chooser table, is how they have called functions in the chooser table. So I did make a video on this to go over how they are exactly doing that. And what they're doing is they cache this data, or at least set these references in a different part. So, with the velocity here was set within our update essentials values, where we get it down here, where we're updating our current, our target velocity, stuff like that, and setting in here and doing our mathematical operations in here. And then we get to now call in here. So likewise with our future velocity, where we're doing our referencing and mathematical operations and stuff like that within the generate trajectory function. So now all that's left here within the is moving function is that we now just have pure, and I mean pure, mathematical operation. That is the main requirement here, because you can call any function pure as long as it has a return output, because with a pure, it no longer has execution pins, so you can't, move through data through this and make modifications. You have to then do pure mathematical operations in here and have a given return value in order for it to be pure. So that's part one of a pure, is that it has to have a return value and it needs to be strictly operational or mathematical, because it's going to lose its execution pins. The other part of it is that we now need to make it thread safe. This is also important because we need these variables by creating them elsewhere, setting them as variables, and then allowing them to be called in here and doing purely mathematical operations in here in order for them to be thread safe. So let me demonstrate. So let me compile and save it. But now let's do this, right? It's a pure function and it's thread safe. What happens if I just disconnect velocity, right? So let me go ahead and disconnect that and just move it up here. Say we want to grab our character's movement component and then get the get velocity. I think this will work, but I don't think it will either, because I think now we have an object reference, I believe. I don't think this is going to work because I did it before. Yep. Okay, that's why I wanted to make sure. So as you can see, because we have an object reference, or that's, of a component type, also actor types aren't going to work either, just because of how they're referencing certain data. I need to do more research on it to find out. All I know is that it's not because of how it's an object reference for either a component or an actor, it is not getting appropriate mathematical operation data. Yes, we are getting velocity on it. However, velocity is a mathematical operation. The component is not. It will give you stuff that you could do that with, but we are getting stuff that won't be able to do calculations and other stuff. So that's why I was trying to mention where for this, we need to have purely mathematical operations in order for this function to be thread safe. So, and thread safe is a requirement in order for it to be put in the chooser table. So with that being said, let's go ahead and put our comment bubble in here, and let me move stuff around because I know I kind of edged it a little bit too far out. Just like that. Perfect. Just like that. So as you can see here, we're going to look at the current and future velocities determined by the trajectory generation. This was made in the update essential values. This was made in the generate trajectory function. and this will determine if the character is trying to move or is currently moving now and is trying to move in the future. So and then you can see here, or trying to stop, because if it's trying to stop in the future, then this is going to become false, because then our future velocity will be 0, so then it'll return false, and then it'll allow us to play stuff like stop animations, other stuff. However, because we have a pure function that is checking if we're moving now and in the future, this is not going to work with the, the walk, run, sprint starts and stops. So, or it will with the starts, but not with the stops. So let's go ahead and compile and save that and head back into our update states. And now we can grab our isMoving function, and as you can see, it is a pure function that offers a return value and is the same as the one shown in the game animation sample project. So now that we got that and we understand what's going on within here, let's go ahead and move the comment node in here and then move it up here. And then let's go ahead and plug that in. So now we are on the next part. So let me actually move these up real quick. Just like that. And now we are on the gait movement. So I did do a separate video on this. However, it was to set up the gaits for crouching. So I'm not going to do that in this video. All I'm doing here is going over how the gait selection is working here. But if you want to see how to set up the gaits for crouching, because I know that you don't want to leave them on any, please by all means go ahead and check out that video if you wish to, so that way you can see how you would need to make those changes in order for you to set walking or any on your crouch movements. So for this one, let's go ahead and get into it. So I'm going to then actually, let me change the isMoving category to movement analysis, because this is now the next part, or the next category for it. And then in here, we're going to go ahead and get our gait, just like that. And then we're going to look for eGait. And then we're going to duplicate it just like the other one, and we're going to get last frame. So similar to what we've been doing is, we get the current gait at the time and we're caching it into the last frame, just like that. And then what we're going to do here is now we're going to grab our character reference. So I know it's not the same as the GASP one, but it's the same method regardless. So in there they have their sandbox character reference. Here we just have the basic character reference to our BP third person character, which is still the same thing because that's where we have our gait in there. So what we're trying to do here is that we're not trying to call the gait within here, because what we're going to be doing is off of our character reference, because that's where a lot of our functionality is stored, like our calculate gait speeds, setting our gait in there, our aiming is in there, stuff like that. We want to grab what's already set in there so we don't have to remake it in here. So off the character, what we want to do is do the get gait, and what we want is this movement. We don't want the get desired gait, because this is what is actually setting the gait variable in there. So if we go into the BP third person character, you will see under movement how we already have the gait variable made and how it's being updated in our movement here. So when we went through the get desired gait section in the character blueprint series, of how I went through the lengthy discussion of what's going on, to where, if certain Boolean checks are correct, then how we get our return nodes for sprint, run, walks, etc., stuff like that. So we're trying to call that specifically. We don't want to call what's in our animation blueprint. We're specifically wanting to call what's in our character blueprint, because we already have the functionality to get the correct gait in there. So then off of that, what we want to do is do a switch on gait, because depending on whether we're walking, running, or sprinting, because these are our return variables, we then want to set our gait in here. So I know what you must be thinking. I just said, well, Silver, you just said that we don't want to set it in the animation blueprint, and we don't want to set functionality that's already existing in our character blueprint. We just want to set the appropriate nodes, you know, for the already existing functionality in here. Because imagine you know, that's why you'll see tutorial videos where, you know, people will do certain things where it's like, hey, you want to aim or you want to shoot your gun. So, you know, they'll create booleans in their character reference and then get their character reference in the anim blueprint and then call that boolean value in there and then do another set node in there, because we want to set the animations to whether that, you know, value is true or false within the character blueprint. So, you know, because we have this, if we actually want to sprint, like when we hit our left shift and we start sprinting, then that will be true, which will then pass through here if we have a full stick deflection or a full button press, and we will then sprint. So when the return value on here is set to sprint, then it's going to update our gate right here, which will then shoot that update through here into our switch, and it'll be like, oh, he's sprinting, oh, then do this gate. Because anything within the chooser table, you know, within that, you have to set these variables in the animation blueprint or you will not be able to call them in your chooser table. So that's why it's important to set up whatever functionality you need in there and then call it appropriately in here. So, you know, if we're walking in our character blueprint, then we're going to set up we're going to then walk our walk. You know, if we're running in our character blueprint, we're going to run our run and then, you know, sprint, do our sprint. So that, hopefully I explained that well enough. I know I basically kind of repeated the same thing 20 times, but what I'm trying to do here is to make sure that the point is kind of driven home, because it was definitely something that was confusing to me when I first started learning Unreal Engine 5, was I would see people like, here's how you aim, or here's how you shoot, here's how you pistol, and then, you know, they don't explain why they made it in two different places. They only show like, all right, do this, and then they have, you know, the is pistol in the character blueprint, but then they called it again in the animation blueprint. So just the basic synopsis of that, or the basic summary of it, is in the character blueprint, you want to set the functionality in there first, and then functionalize it, whatever, you know, that's not even a word, but do that, and then call it kind of like how they're doing in the character blueprint, where now you're setting that here as the variable, and then we call this variable in the animation blueprint, because now we want to be able to do different animations based off that functionality. So don't waste space in the animation blueprint creating the functions. Do it in the third-person character template or the GASP, you know, sandbox character template, and then call it into your animation blueprint in order to be able to get those animations like up and running. So now that I've given that long, lengthy, repetitive talk, let's go ahead and put that comment in here. And then let's go ahead and move that back up into here. Let me expand it a little bit. I know I made it a little bit thick, but let's do that and then connect our pin. And then the last one that we are getting is our crouching state. And this one's pretty simple. You'll definitely have seen it in the third-person blueprint. Or not in the third-person blueprint, but you will pretty much have like made it before when trying to make state machines, but not like this. But let's go ahead and add our stance, and we're going to get our E stance off of it. I hate this one in particular because it makes me do this. And then let's go ahead and duplicate it and call it last frame. Jesus Christ. All right, if I can spell. All right, and then same as before, we're going to get the current stance within our enum file, and then we're going to cache that into our set file or set node, and then we're going to then grab our character movement, and we're going to grab the built-in is crouching function for our nav movement, and we're going to then put that to a branch variable. Let's connect that, and then let me move that back ever so slightly. And then off of that, let's go ahead and set our stances. So if we are crouching, then we're crouching. And then if we're not crouching, we're standing. It's pretty straightforward. So just like that. And then now we can put the last dev comment in there. So like I said in the beginning, I just didn't do, you know, like more descriptive comments in it, because once we get through the first initial, you know, few of them, that I was hoping that it would become self-explanatory for how they are actually working. So let's go ahead and clean that up. And now for the piece de resistance, we are going to grab the big chungus text node, or the comment box, and I'm going to plug that into here. I like how I never hit the mark or come even close. All right, just like that. Yep. So now, as you can see with our big one, that this function caches all important gameplay relevant states, you know, like whether we're on ground or in air, if we're standing or crouching, are we walking, running, sprinting, you know, etc. Saves at the last frame. So like I said, it's going to get the first initial value off the movement, you know, off of the, you know, the enum file, cache it into here, then it's going to do its process, and then it's going to then go down to the next one because it's part of a sequence, and go through this, and then same process with this. So once it finally goes through all 5 of these is when it then has to execute the other parts of the blueprint, and then circle back around to then check, like, hey, are we on ground or in the air with our next frame? Then we're going to cache that in here. Are we orienting to movement or strafing? Cache that into here once it loops back around. You know, whatever value it exits with, it'll then restart into here. So other than that, guys, that is pretty much it for this video. So let's go ahead, and I'm going to close that, close that, close that, close that, and close that, and then we can go ahead and add, yeah, let's go ahead and move. Oh yeah, I gotta make the movements real quick. So let's go ahead and create our category. We're going to call it states, and then let's go ahead and move all these in here. Can I do multiple clicks? No, I can't. Okay, so now that we got them all into here, let's go ahead and close that up, go into our event graph, and let's pull out our update states and now connect that. So now we are officially done with the event graph set. We've set up our first pure thread safe function that will be used in the chooser table when we eventually get to that. And then, you know, we have our update states, we get our generate trajectory where it checks our future movement, detects our future velocity, and then we have our update essential values. Although, like I said in that video, we are not using all of those values. However, we are definitely using, I'm pretty sure, half of them somewhere. Like as you saw, from the generate trajectory one, that we have used the future velocity in there, and how we grabbed velocity out of essential values and used it into the is moving. So I believe in the next video, what I'm probably going to do is I'm going to set up I'm going to go look through the other movement analysis functions, because I believe now we can actually start putting all of those together to be able to be used elsewhere. So that is pretty much what we're going to be doing in the next video, is getting all of those pure functions set up and discuss what they're actually doing. So hopefully you enjoyed this video, guys. If you did, please check out my other videos and look out for my future videos to come. But other than that, y'all have been great so far. Y'all have a great rest of your day, and take care.